discussing yesterday?
Actually, I saw Kishan's question left view.
Mm-hmm.
Oh, I didn't hear your question. You're asking about what we did?
I just asked like what we were discussing yesterday. That's it.
Oh, okay. Yeah. I mean, yeah, this was it. This is
Mm-hmm. Okay, did anyone try to do the like implement the okay, we saw K notes count solution, correct? Did anyone saw the implementation of a min heap?
no.
No? Okay. So for now, if you have not seen it, like it will be not good if I discuss the solution based on heaps. So let's keep this topic on a hold along with tries. At the end, we'll discuss few questions on that. Sorry, Kishan, I didn't get your question as well. What you were supposed to do. Okay, you remember that day we discussed how a min heap is being formed? You were taking a number, you were making it as a node, and I told you that a heap should follow a CPT and all the nodes inserted should be less than or equals to the child node. That means child node should be always bigger than or equal to the parent node. So how this specific tree is being formed, that was your task to do. Okay, that is what we call as in. So okay, so using CBT we need. Yeah, correct. So basically you need to implement the CBT property in a min heap, and then you need to do your insertion in a min heap, getting the minimum element from the min heap, and then what was last? Deleting the element from the min heap. So these are the three operations that you need to perform, and you need to write the code for this. Based on your understanding, I will discuss the questions on min heap. Clear? Okay, so right now I'm skipping this topic because like the trees has got little heavy. So I am okay, you will do that by tomorrow. That will be great. But since trees has got little heavy, so I'm just skipping this for a while. So try and this heap we will keep for later. And today I'm gonna begin the DP. Will it be fine? Okay. So three topics remaining mainly, which are DP, graph, bitwise. Then comes
Ma'am,
the miscellaneous. Sorry.
ma'am, one thing I was not clear. Kishan asked this question that he ran that code in the hacker rank.
Mm-hmm.
That
Yeah.
question itself is not clear, like how the input and output is related. I can put that question like,
Please do. Yeah, please do put the question in here, the chat. I will just open in front of you and I can explain that to you right now. Will it be fine? Actually, I didn't got a chance to open that solution and check it out. I'll just give me a minute.
yeah, I put in the chat.
Okay, so I'll just open it. Um, okay, are you guys able to see my screen?
Yes, I do see the screen.
Okay. So what is the doubt here?
So the input is 3, which means that 2 times that many lines would be there for input, which is 6. So that I understand. Then it says like 5 is the number of elements, then 1, 2, 3, 4, 5 is the first tree, and the output is for the left view is 1, 2, 3, 4, 5. This also I understand. But then after that, the second input is 3, 2, 4, 1, 5. And it's not clear how is 3, 2, 1 the left view of the tree. So in that, when I draw the diagram, it is not clear where is 4 and 5 located in
I
the
got
tree.
your doubt. I got your doubt. I'll just tell you what problem you are facing. It's because did you made the tree after getting this array? Did you try to make a BST on your own manually on a pen and paper?
Yeah, I did.
Okay, can you tell me how should the tree be found?
Yeah. So first one is linear 1, 2, 3, 4, 5 in a line.
Yeah, no,
So
just tell me for this because you understood the first one, right? So just we'll discuss the second one.
yeah, so 3. So at the root is 3, then 2, then 1. 4 and 5 are on the right.
First tell me what should be on the left.
3.
3 is the root, right?
Yeah.
What
I
should
mean,
be on
either
the left?
3 or 1, any one, 3 or 1. I'm thinking 3 is the root because it's a binary search.
See, that's the problem here. That's why I asked you, did you made the tree and you said yes. So 3, you got your first number, make it as your root node. Okay. You
Yeah.
got 2, you know that 2
to
is
the-
smaller than 3, shift it to
Yeah.
the left. 4
Yeah.
you got, make it to the right.
Yeah.
1 you got, 1 will go on the left. Then when it check with 2, again 1 is smaller than 2, it will go to its left, right?
Yeah.
5 when it will come, it will go on the right hand side of 4. So here it will come. This is the tree structure. Clear?
Okay.
Now, if you're viewing, like let's suppose you are standing over here.
Yeah. No, I'm clear. Let's do the last one, 4, 5, 15 one. Now I'm clear 100%.
4 will come here.
Yeah. 4
See,
root.
that's the thing. Everything you guys want me to do.
Oh, okay. No, okay. Let me see. 4.
Okay, because like it was very simple. I have told you how to insert it in a tree.
Right.
You could have manually made a tree and you could have found out your answer. Clear, no? Just pay little more attention in the class.
No, ma'am. No, 1 and 7, where will it go?
Oof, okay. So 4 will come here. Then
Yeah.
5 is bigger than 4, 5 will come over here. Then 15, bigger than 5 also, here it will come. 0 is smaller than 4, it will come over here. Then 1 is smaller than 4, it will come to the left. But 1 is greater than 0, right?
Yeah.
So it will come on the right hand side of 0.
Yeah.
7 is bigger than 4, so it will go to the right. 7 is bigger than 5, it will go to the right. Then, but 7 is smaller than 15, so it will come here. Clear?
Yeah.
17 bigger than 15, it will come over here. When you will view it from the left, 4 will appear, 0 will come, 1 will come, and this 7 will come. That's your
Okay.
output 4017.
Yeah.
Clear?
Thank you. Thank you.
Okay. So that was the entire logic about.
Yeah, we'll do it now.
Good. So let's start the TP. It's a huge topic we all have been anticipating about till now. Right? Anyone who was excited about DP?
Yes, I am excited.
Okay. Let's start with the very basic questions, and then we will move ahead and see. Okay. Okay. So everyone knows about the Fibonacci series. It's basically sum of two previous numbers. If you have one, like you initialize the initial two numbers as one, the next number is gonna be two, the other is three, then 5, 8, 13, 21, and so on, right? There are two possible solutions for this to be done. One is to do it recursively, one is to do it iteratively, right? Okay, so we'll just see both of these solutions. If I have to do it recursively, can any one of you in the class tell me the solution for it if you remember it? You will be given n and you need to return the nth Fibonacci number. Yeah, please dictate it. And someone also dictate the iterative approach. Is anyone gonna unmute?
Yeah. So, iterative, should I go?
Yeah, sure.
So while I is less than n,
Okay.
um,
What is your I? You have not declared it yet.
oh yeah, int I equal to 1,
Okay.
while I is less than n. So keep adding. So it will be I plus I. So the next number would be I plus 1.
No, it's like you have to take some of your array for memorizing the values which you're gonna add further.
Yeah,
That
yeah,
is, you will make your array for n plus 1 values because you want the nth value. Okay, that's why I'm making the array with n plus 1 values. I don't think so the reason is needed here. Then next you should do is not less than but less than equals to n because you need to go till n.
yeah,
Next is if you need to find a of I is nothing but it is sum of its previous two values, that is a of I minus 1
a
plus
minus 2,
a of I minus 2.
2. Yeah,
And after this, you can do your I plus plus. But since you know that initial two numbers should be initialized, right? That is array of 1 and array of 2 should be initialized. Are you guys able to follow?
yeah.
Yes. So you can easily do that by writing array
Array
of
0
0.
and array of 1.
What should be array of 0?
1. Oh, 0. I mean, 0 and 1 will make it 1 in the next. Uh,
You can take it as 0, better.
yeah, and
You
array
can
of
take
1.
array of 1 as 1 and you can initialize your I with 2. Okay. and then it will continue. At the end, whatever your answer will be in the array of n, that will be your answer record.
Correct. Return an.
Clear?
Yes.
Same doing with the Fibonacci of recursive way. It's like right now we discussed, or just a minute, to make both of them align, I'll just make it as one also. That will be better. If n at any point is equal 0, or n at any point is equal 1, in that case you need to return 1, right?
Yeah.
Yes. Other than that, you simply can write return, yes, Fibonacci of
Fib
recursion
n.
n minus 1
1.
plus Fibonacci of recursion
N minus 2.
n minus 2. Clear?
Yes.
Any exceptions?
No.
This code will work fine. Okay. Can you tell me the time complexity these two codes are going to take? Will both of them take order of n?
No, I'm thinking it'll be n square in recursive because we are calling it twice.
So this will be order of n square. This is order of n. Any
Yes.
other vote? Guys, I'm waiting for your answers. Okay, no responses indicates that you guys are fine with this answer. So everyone, if you remember when we learned recursion, we did this Fibonacci series problem, okay? And it gave you the recursive equation as T of n equals to T of n minus 1 plus T of n minus 1. So it was almost like 2Tn minus 1. Sorry, my bad. Plus T of n minus 2 and plus order of 1. Yes, if anyone can just rotate or go back to your notes of recursion and tell me what was the result of this recursive equation. Anyone remembers it?
Ma'am, this would come out to be n only.
Are you sure?
Yeah, because ultimately the most significant would
See,
be
the
n.
thing is, it's not like you are guessing here. It's not a guessing game right now going on. I've told you to specifically calculate the answers for the recursive equation. Yes or no? Yes. So you should tell me the specific answer for that. Take 1 minute because right now I'm not going to disclose the answer for this. Okay, I got it. It's order of 2 to the power n. Guys, it's really, really bad how you guys are progressing in this course. You're forgetting the very basic question that we discussed in recursion. For this, obviously, you can see that I is running from 1 till n. So obviously, it's going to be order of n. So this is fine. And for Fibonacci series, it's 2 to the power n. So my question here is, both the codes are giving you same results, but still why there is such a huge difference in the time complexity? Can anyone tell me that? Like same problem, different solutions and different time complexities, why? And that too such a huge difference. Can anyone identify the reason? I am giving you to observe it for some time, like take 2 minutes.
Ma'am, can I say?
Sorry?
Can I say what I'm thinking?
Yeah, sure.
So both are being done separately. Like by that, what I mean is Fibonacci R, that is recursive for n-1. This is being added separately with respect to n-2. So in order to get Fibonacci R, yes, we need to add like the last two numbers to get the last number.
Not
So it
clear.
is, so no, so supposing if we are doing for 21, so we are adding 13 and 8 separately. The both functions are doing their job separately, so it is 2 times more. Whereas in case of iteration, we begin from the start, scratch, and go all the way till the very end. And they are doing in a linear fashion, keep on adding until the end.
Yeah,
So it is,
exactly. Observation is correct, just the words are little bit, complex. So I'll just explain it in a simple way. If you have got a number n, okay, what you are doing, you are first finding out the result for n minus 1, then you're finding out the result for n minus 2. Then again, you're finding out the results for n minus 2, and then you're finding out the result for n minus 3. Here again, you are finding the result for n minus 3, then you are finding out the result for n minus 4. This series continues, and this also continues until they reaches 1 or 0 probably. So what is the thing happening here is you are getting repeated function calls. N minus 2 when you have already calculated n minus 2 after n minus 1, why to calculate it again here? N minus 4 again, it will be repeated somewhere. So the thing here is you are recalculating the values you have already calculated. N minus 2 is already calculated, but when you go back traverse, and you visit this function call, you will calculate n minus 2 again. And that is consuming a lot of time. Clear? While in the iterative approach, if you see, once you have calculated the answer, you are just reusing it. You are not again and again going and calculating the answers for all the possibilities. Are you? No. So basically, these kind of problems or this kind of observation where problems are getting repeated, we call them as an overlapping subproblems. So you can see the problems are overlapping, right? If you got n minus 2 over here, you're getting n minus 2 over here as well. So it is overlapping with each other. And hence we call them as overlapping subproblems. So this is the very basic step. If you are learning DP or if you're trying to implement DP in any question, the first thing you need to look for in any problem is overlapping subproblems. if there exists a overlapping sub-problem in that particular question, that means TP can be applied in that specific question. Clear? So this was the observation that I wanted to show you all. Now, you already know that if you have calculated one of these stage, it should not be calculated again, right? That is our observation here. So what you can do here, you can modify your recursive code a little bit. You can pass here along with n, you can pass int array of n+1 size. Okay. Again, but like the conditions will be the same, just you need to see, you can fill this array of n+1 with all the values -1. Okay. So you just check if array of n is still equals to -1. If it is equals to -1, that means the value is not updated, right? Are you guys getting my point? If the value is not updated, then you can simply do array of n should be equals to Fibonacci of n-1, comma array plus Fibonacci of n-2, comma array. Clear? By any chance, if this is not equals to -1, this indicates that you have already calculated that value and you need not again calculate it. Clear, guys? The base condition remains the same.
Ma'am, 1 second. I'm thinking that it will never be array of n is never be equal to -1. So should we put not equal to?
No, actually what I'm trying to say, whatever array you have taken,
Yeah.
you by yourself fill all its values with -1 by default.
Oh,
Okay. So when you are calculating the values, you will first go through this check that if the given value is equals to -1, this will give you an indication that that specific value has not been calculated yet. Clear?
right. Yeah.
So if it is not has been calculated, then you will give your function calls here and you will calculate its value. Clear?
Yeah.
But if it has been already calculated, that means if you're getting that overlapping sub problem, in that case, you need not enter this if condition, and that will save you a lot of time.
Got it. Yeah.
Clear?
Yeah.
Yeah,
Clear.
correct. Kishan, you need to return array of n at the end. And here for if n equals to 0 or n equals to 1, how you are handling these cases? You again here can simply specify return
Array of n.
1. No, that's it, return 1. Clear? So when like right now, if you will see, the function still looks the same like the previous one, but just including this if condition and the array has dropped your time complexity from 2 to the power n to order of n. Clear? So that's the impact of dynamic programming. Clear, guys? Okay. So now we optimized our time complexity using DP. There is one more term that comes in DP, that is space optimization. So space optimization, how you can do, you can clearly see that your current stage is only dependent on previous two stages, right? Is it dependent on I minus 3, I minus 4, I minus 5, I minus 6 anywhere? No. So instead of using these like the complete array, you can initialize two variables. First, you initialize your I. Initialize, imagine your first number 1 is A, your second number also is 1, that is B. And you are trying to calculate the third number C. So C here is gonna be A plus B. Yes or no? Sum of two previous numbers? No, I didn't understood. Okay. So C equals to A plus B. Now you got your current number. That means you have 1 as A, you have 1 as B, you have got 2 as C. Now what should be like to get this number at the 0, 1, 2, third index, how will you calculate your number?
Add previous two numbers. Okay. So for space optimization,
Mm-hmm.
n minus
Sorry, I
1.
didn't get you.
So we'll just add the previous two elements by going n minus 1, or n minus 1 and n minus 2.
These are two previous numbers, A and B.
Yeah,
Now you have got your third number C as well, that is 2.
yeah.
Once this is done, is there any use of this A anymore?
No,
In order to find this third, like the number at the third index, you will only need B and C, right?
yeah,
So now just swap your values over here. Are you able to follow?
yeah. Assign B into C
Okay.
and
And
assign uh, C,
first you
sorry,
have to assign
A to
B
B,
to A,
and yeah,
not A to B, it's B to A.
yeah, and C to B.
And you need to assign C to B. Correct. Clear?
Yeah.
And at the end, what you are going to return?
C.
Okay. You can return C, that will be fine. You can also return B, that will be fine because at the end you are assigning your C to B, right? So that will also work. Clear, guys? So now what we did here, our space complexity, which was n, right now we have modified the space and we have got our space to order of 1. Clear? Can we do the same in the Fibonacci of recursive approach? Can we modify it further to reduce the space in this specific solution? No, we can't. Because we always need a check in the Fibonacci of recursive approach that whether that particular stage has been calculated or not. Okay. So that's why we need to keep the array over there. It cannot be optimized further. Clear, everyone, with the approach, with whatever we have applied so far? Oh,
Currently, the recursive one, the space is just n already. Like we are not storing anywhere else these values, so it's already optimized.
didn't get you.
So my thinking is that in this we are just having array of n, which is the input. So
It is
it is,
not an input. It is something which I am passing from the main function to calculate the Fibonacci of recursive in this way. It is not an input.
Okay, okay. So again, it is already optimized because we are just having one space complexity. We are
One
not,
space complexity of n size.
yeah, we are not adding or deleting anything inside this.
You're not getting it. You have this array of size n, right?
Uh,
Which is
yeah,
itself a space complexity of order of n.
correct.
So it has a space complexity, right?
Yeah,
Yeah. And it cannot be modified because at every stage you can see you're checking if that specific stage is calculated or not calculated.
okay, yeah,
Correct?
yeah,
So hence it cannot be modified.
okay.
Clear now?
Yeah, yeah, clear.
Okay. So from the above two observations, I'll just like to explain you guys that DP basically has been divided into two parts. Either you can solve your DP problem via recursion with memoization. Memoization in the sense you currently saw that in order to store the DP states or in order to make program memorize certain stages, we were storing it. So that we call here memoization. The next you saw the iterative approach, and that in DP we call as an tabulation. Clear? Yes.
No, ma'am, one thing, so calling the function within a function with a -1, is that the memoization?
Mm,
So I'm just trying to correlate what we read. Is
you
that
used an extra space here, right?
okay?
You are
Yeah,
using the recursion and you are using an extra space to reduce the time complexity of your recursive approach,
yeah,
right?
yeah,
That we call recursion with memoization. Memoization means taking some extra memory or taking some extra space.
yeah.
Tabulation is simple. Tabulation means an iterative approach.
Got it.
Clear?
Yeah.
Okay. So if you guys are clear with these two terminologies, I'll just move on. So to find out the time complexity, like if you see the time complexity you needed to find in a recursive approach was easy. But in a recursive approach, the time complexity you can calculate with knowing the number of states you're going to have. How many number of states you are going to have in the Fibonacci series?
States.
Number of
Yeah.
states means the number of values you need to cross to reach n or to specified value.
So N.
N, right?
Yeah.
Did you get it now?
Yeah, because we are temporarily storing in the arrays.
Um, yeah. Kishan, basically number of state means the size of the array which you have taken to calculate the values ultimately to reach n. That is counted as number of states. Does it make sense now? Everyone else? Yeah, using memoization approach. Correct, correct. Next is if you multiply the number of states with the time taken to calculate one state. So number of state you had was n. Time taken to calculate one state was very simple. You already have your pre-calculated states with you. You just need to add two previous states to get the current state, right? Are you guys able to follow here? So that will be one. Overall, your time complexity comes out to be order of n. In this, to calculate, like basically in this DP problems, you don't call it as in space complexity, you call it as in table size, the DP table that you created. Terminologies are different, but the concepts are same. So table size here, it's gonna be
And
n, right? Guys, just give me a minute. Okay, so you understood the space complexity, you understood the time complexity, and that is done. Now there is a problem which I'm gonna give you for you to think and then come back with certain approaches to it. Okay, so you have an staircase basically up to n. This is a very classic problem of DP. You might have heard of it or not, I'm not sure. So this is your 0th stair, first stair, second stair, third stair, fourth stair, fifth, and it goes. To reach the nth level, you are, let's suppose here, you can either jump or take one stair, like you can jump one stair at a time, or you can directly take a jump of two stairs at a time. Like either you can take one jump or you can directly jump, like you can skip two stairs at a time and you can directly jump to the second stair. Are you able to follow? Yes. Okay. Knowing this condition, you have to reach till the nth stair. Okay, are you getting it? And you have to tell me in this particular question, how many number of ways you can climb up the stairs. Clear? Like if I tell you here in simple for more explanation, if you have to, let's suppose n is equals to 5, you have to reach till n equals to 5. You can reach like 1, 1, 1, 1, 1. You can reach like the other way can be then you can have 1, 2, 2. Then you can have 2, 1, 2, and then you can have 2, 2, 1. So total number of ways you can climb up the stairs are 1, 2, 3, 4, 5, 6, 7, 8. 8 is the answer for this. Clear? Yes. So you understood the question? Okay. So try to do it today. And otherwise, we'll discuss this specific question tomorrow, how it can be approached, how it can be done. So I just gave you a very basic idea of DP today, like what is DP, how to know which question follows DP and where to apply DP. I just told you the two ways in which we can apply the DP. One is recursion with memoization, the other is tabulation. So these were the few terminologies I just explained. There are more which I'm going to explain tomorrow. So please don't miss the class tomorrow. Clear all? Okay, perfect. So thank you for attending today's session. And
Whiteboard link.
yeah, thanks for the reminder. Okay, so I've shared the whiteboard link.
Thank you, ma'am.
Thank you all.